Hello, guys. Welcome to this session, and we'll wait maybe a few more minutes before we actually begin. And can we have a quick introduction? Anybody who has joined, and what you guys expect out of this? So it will be a very nice introduction. Can you guys hear me? I think someone is speaking, but I cannot hear your voice. Probably. Okay, we'll begin now because it's pretty on tight, and we are live on YouTube right now. So I'll start with the key motivation behind this webinar because we have been conducting. Yeah, someone is want to. I'll mute then, everybody. So the key motivation behind this webinar was to give a picture of people who want to onboard into, especially big data analytics, big data technology, and everything is so confusing, especially because a plethora of technologies are involved and so many people are talking, and most of the people are talking just nonsense. Take an example. Nowadays, if you see, everybody's talking about ML, AI, as if they were born yesterday and today they are ML like gurus and everything. And some people, take an example, someone's claimed to be a data scientist when they basically are able to run a bunch of algorithms downloaded from Python library. And on the technology side, there is so much confusion because so many technologies are coming and evolving. What was hot last year is no longer hot anymore. And for a newbie who is just getting on board into the system, they really don't know where to go on. So this is a it's not a session, it's more of a discussion. Feel free to interrupt and we can discuss. So the idea of this is to give a basic overview of what is big data, and then we'll go over some of the options, like now, like a lot of careers. If you're looking for a database career, data career, so what kind of options you have. So big data. So big data is a generic word used for mostly large amount of data when it comes to petabyte. And when I say large amount of data, I mean at least petabyte, and you have structured and unstructured data both. So it has to be both enormous amount of data which you have collected, and you want to manage the whole data at one shot. I'm not saying if you have a two petabytes of data, but every data has its own silo approach. Then it may or may not, because for that purpose, you do not even need to put all data in one place. You can put smaller portion of data into different subset, and in that case, you may not need big data. So classic example of big data will be your Facebook data, Google data, or NASA data. Because NASA, they have been doing big data maybe, I don't know, maybe 50, 60 years. So because they have enormous amount of data they collect out of their research projects and astronomical data. So astronomical size astronomical data, and where they have to take all the data into consideration before they actually doing some modeling, doing some prediction, maybe trying to find some new planetary system. Similar applies to Google and Facebook. They have a very structured and unstructured data and large amount of data, and they have to have a full picture of the data in one shot in order to achieve certain objective. And now there is another side of data. What I call is not really a big data. Take an example, most back office data, employee record, banking transaction data, insurance company data. Majority of the enterprise data is not necessarily big data, although same principle could be applied. Why I'm saying? Because they still have mostly highly structured data. I'm talking about back office data. It is mostly you have employee record, age, date of birth, salary, and all those things. How much it will be? Even if you have millions of employees, it will be only a bunch of gigabytes of data. It's nothing. Again, banking transaction data, if you're talking about credit card transaction, your banking transaction, You will not create a millions of record in your life cycle. So again, the data is mostly structured data. So you not necessarily need to have a massive data lake paradigm in order to achieve your business objective. But yes, you can of course use some of these things. Second thing, so whenever we talk about big data, people always talk about Apache Hadoop, right? And by the way, big data doesn't mean Hadoop. Hadoop is just an implementation, is an open source framework implementation of using a distributed storage and computation on a commodity hardware. This is the key. Because the key idea of big data, if you see Hadoop is in one way, it takes a lot of resources to do even small kind of activity. If that kind of activity, if you have to do in a really enterprise grade hardware, it's not cheap anymore. It's very expensive because it needs enormous amount of storage, enormous amount of memory. The key selling point of Hadoop is that software you get for free, and it is not the best highly optimized software. Take an example. If you want to compare with, a lot of people talk about this guy. So mainframe is a highly customized software. It is very efficient, fast, stable, and that's why you pay enormous amount for the hardware, whoever is selling the mainframe solution. But on the other side, when you're talking about Apache Hadoop, you're talking about a commodity-based hardware where you can install a free software and you can scale now. So whenever it comes to adding a hardware, I'm talking about commodity hardware in PC grade hardware. Like you just $1,000 PC, you add it, keep adding, and in that way you can create a massive farm which can address your big data need. Again, this use case comes when you have so much data and you have to have all data into same paradigm, same context. In that case, you will use it. So quick view about this, your Hadoop components. So Hadoop components, if someone wants to think that you will understand all Hadoop components in 5 minutes or 1 hour, they are just dreaming. It's not possible because it's a very complex system. So Hadoop usually involves a bunch of things. Like key is that Hadoop distributed file system, which is called HDFS. And on top of that, you have a resource management system, which is like your CPU scheduler or anything. Then you have their key batch processing algorithm, which is called MapReduce. And then on top of MapReduce, a lot of things have been built over a period of time. Like for scripting, Pig has built. Pig is mostly catered towards your ETL developers who have ETL experience and who have SQL experience. Another one is Hive. Hive was again invented by Facebook. The key was that big data is if you guys know a little bit about data warehousing, there are two concepts. One is schema on read and schema on write. So majority part of Hadoop is always schema on read. It means you dump the data. While dumping, you don't know the schema. But while reading the data, you can actually find what is schema and all this thing. So for that purpose, and because most of the people are familiar with SQL, so this was invented so that you can have some kind of SQL kind of interface and you can see and visualize your data using various tools. And then you have HCatalog. And on the other side, you have a NoSQL database, which is HBase. It's again sitting on top of HDFS. So everything is based on HDFS. And everything in Hadoop, it relies heavily on HDFS. It's fault tolerance ability to have, like, anytime your commodity hardware can fail and it will recover from there. Other application, you can have graph APIs. And then you have, now this is your Hadoop. And then I'm talking about, you need to bring data into Hadoop from different sources. So your Flume could be one solution where you're actually Flume and Scoop. Scoop is usually used to bring data from your traditional database like Teradata, Oracle, MySQL. You can bring the data in here. And you can have third-party plugins like Microsoft Power BI and a lot of like Splunk. You just name it. Pretty much everybody supports. And on the left side, what you see in the green, these are all operational activities. Like if you are take an example, Hadoop admin, you will be mostly dealing with whatever you see on the left side: Ambari, Uzi, Zookeeper, security and governance, which is Knox. Right side, what you see, it is mostly for BI people who are interacting with Hadoop, not necessarily a developer. And what you see in it, like hold this, whatever is in the between, it is mostly for developer, Hadoop developer. And this was the Hadoop. So this is just a given understanding, Hadoop. And then now you hear a lot about Apache Spark. People in the industry, people are talking about, okay, Hadoop is, we are bored of Hadoop, is now we are whatever it is. and now people are moving to Spark. So what is Spark? Just a quick nutshell. So Spark was the MapReduce. If you see, these are all coming from Wikipedia. Nothing is rocket science. Everything is open source. The goal of this quick webinar is to just give a summarize entry of this, summarize information. So Spark and RDD was introduced in a response to MapReduce limitation. MapReduce, what was the limitation? First is that the way MapReduce was designed, they did multiple iteration of MapReduce also. First version, one Hadoop and Hadoop 2, they are improving, but the key concept remains the same. In MapReduce, you create a job and you give the task to the cluster, and the task is spread across multiple nodes, and you cannot do anything, and you will not do anything till actually task has finished, and they on the reduce step they collect and give it to one. Is a simple example is if you have a big log and you want to cut the log into 10 pieces. One option is you give one guy, they will cut on 10 pieces, or you give 10 people and they will cut the log each and one at a time, and they will give it back. So basically you can get a 10 times speed. But in practice, it was a disk-based system and network IO, whatever the reason. It is a very good system, but it is not very time performant. So then Spark was evolved over a period of time. It was able to address some of the limitation, and it got really a hit on the people, especially in this community. And second key factor of Spark getting popular was over a period of time, the RAM became very cheap. So RAM and the Spark is a very RAM heavy. So because RAM become cheap and also the hardware architecture change, it can support large amount of RAM. So now you can have an enormous amount of RAM in order to support Spark needs. In Hadoop, in a MapReduce, you may do with a little less RAM. So that was one of the reason why Spark became more adopted. So quick example of a comparison side by side. I will not say comparison. A lot of people think that Spark, Hadoop are competing. Yes, they are competing on certain space, but not necessarily on every place. So they basically sometimes, you can say they can complement each other. Sometimes you need a very speed. A simple classic example, I will say, if you have a batch data means it happens only once in a day. Hadoop maybe is still good solution. If you're looking for more of a streaming data, take an example, Facebook click, or you want to see how many clicks are coming, or IoT data. In those kind of scenarios, Spark is a very good solution. So quick example here. So you have a MapReduce and RDD, and Apache Hadoop is a cheap commodity hardware, and Apache Spark is your heavy on RAM. And one key thing, what I found about Apache Hadoop was the API was not very easy to use. You have to be a rockstar Java developer in order to do a nice MapReduce job. But what happened with Spark, it gave a very easy to use API like Python, R, Scala, Java. So even non-developers like data scientists, data analytics people were able to use it. So it has led to an adoption on the community side also. So this was, I will say, the last option is the key. Why it became so popular? Because easy to use API. Very easy to use, and you don't have to know everything. And for MapReduce, you have to be a good Java developer. And one of the few things as we discussed on the agenda was Elasticsearch and Kafka also. So Elasticsearch comes into realm of NoSQL database. So simple use case, when you are having a NoSQL is a full text search database. A quick example of any database like Elasticsearch, your Google search. When you do any kind of search, when you just type something and it searches the whole database for you. You don't necessarily have to do a select star or something like that. So this gives you a very good use case for users. Second, it is not ACID compliant. ACID compliant means when you do a write, when the API returns, there is no guarantee that data has been written everywhere. This is the key differentiating factor. So if you're looking for a transaction processing or bank data, I will say you stick with Oracle MySQL, because when you do the write, it is guaranteed that file has been written and when the API returns. But in Elasticsearch or any kind of these kind of distributed databases, when you do the write, it just API returns, I'm successful, but it may not have replicated to all the shards. And same thing applies to your Kafka also. So again, it's designed for distributed computing rather than centralized computing. SQL versus NoSQL is a very classic textbook-based system. So NoSQL is designed for performance, and relational database is designed for integrity. Same way, schema and non-schema. And one thing is that sharding. In NoSQL, you have auto sharding, and relational database do not support by default sharding. So there are a few things, but again, these I will say these are not competing with each other. They are just different business use case. You have to understand what is the business use case before you apply.
I have a question.
Yeah.
I have a question. Can you explain what is sharding?
Okay, so sharding is what happens is in any NoSQL database, you have two things. One is replica and one is shard. So shard is that anytime you save an index, or in Elastic world it is called index, and how in relational you call it table. So in an indexing world, whenever you create one index, based on the configuration, it will create multiple shards. Shard is actually those many indexes for computation purpose. So replica is when you say I create a say file, so I'm hello world. Okay, when I say replica, so it will create two replicas. So hello world in two server, it will be identical copy of the data. And shard is that I can take the hello world and divide into multiple shards, so that when I do the query, when I search it, Elasticsearch will fire those many queries, and it is basically more for parallelism. So if I have 3 shards, it means my query will run faster because it will run 3 threads in order to give me the data. So the data is spread across multiple shards, and when you query it, the algorithm will collect from these all shards and give you the data at the end. So it gives you a very good performance. Again, you have to, when you design the system, you have to know how many shards you need, because too many shards if you put, it will create too many threads, and it may eat too many resources. So shard is for parallelism, and replica is for replication. Does it answer the question?
Yeah.
Okay.
Thank you.
So you have again limited query ability with NoSQL. Of course, you have to know JSON query and all this thing. And SQL, you have very well-defined, mature query system. Last technology we're going to talk about today is Apache Kafka. Kafka is what? There's a lot of buzz around Kafka. Kafka is basically, if you want to understand very simply, 101, it is a message queue. That's it. But the way it was designed and the way the parallel approach distributed computing was applied, and plus it was made open source and free, I will tell you, this was the key thing. There are a lot of great message queues are there, but all are paid. But this was a free, and it was used by LinkedIn, and LinkedIn open sourced it, and they now eventually is managed by Confluent. So it is a very good high performance pub-sub service, like publish and subscribe. So anytime you are looking for any kind of streaming data, I will say IoT data or click data, or you can, classic example, LinkedIn notification. This is done on Kafka. So few things: you publish and subscribe, store the record in a fault-tolerant way, very similar, all distributed computing, process stream record as they occur. Classic example is LinkedIn notification. And then Apache Kafka is like an ocean. They have millions of configuration. You can do whatever you want. But on nutshell, it is a distributed messaging platform. So when you publish a message, messages spread across. They have a similar concept like replica and shard. They call them partition and replica. So it spread across the cluster, and anybody can consume it. So this was about the technology side I want to talk about. And now I want to talk about, second part of our discussion, it was like discussing about, data. So whenever we are talking about any kind of data engineering, I assume people who are right now signed up, they are more interested in data engineering. So any data engineering project or any work always require few steps. One is acquiring, second is preparation, last is the analytics part. So acquiring, you have data gathering, sampling, and data preparation is usually data wrangling. And then you have analytics, which is your statistical analysis. So this is your legacy data engineering look like: SQL inserts, ETL tools, Excel or SAS-based system. And then you have big data stack, which is, so you do a data ingestion using Scoop or Kafka. And you have a data prep. You can do a data preparation even in Apache Spark also, and you can use Trifacta also. And at the end, data analytics, you can do on Python, Data Robot, SAS, R-based analytics, Watson. So this was about the basic side of the technology side. And now we'll talk about a little bit on the career side of the data engineering. So a few things about the career. So today we have in a panel, we have two people. One is from a science background, data science background. One is from software developer background. They will share their story, how they evolved through. Before they jump into it, I would like to highlight few of the career path available for as a data engineer. in the data field. One is your data engineer. And a lot of people confuse this job with a data scientist, but it's not. Data engineer is usually a software developer who has Java or Python experience, or a ETL developer who has ETL experience, knows SQL and everything. And they may be knowing Hadoop, Elasticsearch, Cassandra, Kafka, and what their usually day-to-day task is, they do data ingestion, they do data cleaning, they do data transformation. They do not do any data analysis. That is the key part. So this is the thing. So data engineer is mostly a software developer guy who is very handy with data, but not necessarily a data scientist. And a lot of people who think of a data scientist, they're actually talking about this thing. Then you have another one is a data scientist. The truth, historically, data scientist has always been, someone did a PhD or something on statistics, but now with the ease of software, a lot of things are easy. So anybody with a statistical or math background, that is the bottom line. If you do not have this background, you cannot be data scientist. Second is understanding of data algorithms. You understand how algorithm work. You don't necessarily create algorithm, but you have to understand what is going on. Second thing is ability to do feature engineering. Feature engineering is a bread and butter of data scientists. So next speaker will talk, you see how feature engineering is important. And then you basically will be running algorithms like logistic regression, linear regression, ANN, KNN, and so on and so forth. They are like plethora. So these are the key concepts of a data scientist. So again, if you are a software developer, probably if you want to get into this field, you have to get a good basic of math and statistics. Just running some Keras or NumPy libraries will not help you. So what is not data scientist? If someone is able to run a Python code on ANN, KNN, and Udemy, a $10 Udemy course, and you cannot be data scientist. You can run a bunch of code on a hello world data, but the real world data is given, you won't be able to do any to it because you won't understand the feature engineering. Second, a lot of people, they have, okay, I know Panda NumPy, I'm a data scientist. You can call it, but I don't think that is a data scientist. That comes to a realm of what is next we are talking about, data analytics. This is the most popular job. It is all BI developers, like I will say 90% of the data right now you see is this job. And they may call it a different name, but this is what it is. So what these guys are, they understand the data in the sense that not the data of the statistical data. They understand the business value of the data. Like, okay, take an example, you're doing credit card fraud. So you understand what is credit score. So you know how it will impact if I do a default, something like that. They understand this. Also, now if you are a handy, you should know NumPy, Panda, because why you need this? Because Excel-based data will be just too much for you. So it's good for you. So a lot of similarity to data scientists, but not everything. So you should be able to run code, of course, but you not necessarily have to develop the code. The code might be written by someone else. A lot of post-transformation analysis. And typical tools I will talk about: Tableau, Power BI, Excel, SQL, and a lot of tools. And also people are using Python to augment their skill. So if you are a data analytics, you know a little bit of data analytics, and you do some kind of Python understanding, it is a very good skill right now. This is one of the hottest skill. Whatever you see, data scientist, data engineering is a very small part of job. Majority of people are doing this. And then you have a data steward. Data steward is usually, it's a data governance guy who knows policy access and metadata engineering, building data dictionary, like what it means from a business to technology. For technology side, they will say, okay, take an example, capital market. You're saying crude Brent oil. So crude oil, what is the value? So we call it, okay, it's an integer or maybe float point. So that kind of thing, what is in the database, what is name is stored, and how business sees it. These mapping is done by usually data steward. So tool, I will call it, the modern tool, I will say Apache Atlas, and data stage ETL. So these are the few things. So again, coming back to same data science pipeline, you have acquiring and these kind of stuff. So this is I will say this is same thing I showed. So this, if you understand, now it gives you a little bit idea. What is the data role? If you see, so data engineer is mostly their job is stick around data acquisition and data preparation. Data scientist work is usually on the data analytics part. So before you actually do anything, you have to have enough amount of data. So this is all for my presentation. And now I'll just invite our next guest speaker. So I'll first invite Hiren. he has been a software developer, and he started his career like any software developer. But when the technology changed dramatically in past couple of years, how he was able to transform his career from one point to another point, and he would like to highlight on that. So I would like to welcome Hiren. And Hiren, and it's up to you.
Hey guys, can you hear me?
Yes, we can hear you.
Perfect. So thanks, Chandan, for your introduction. And folks, as Chandan said, I've been a software developer, and this is my 20th year as a software developer, and currently self-employed as a software consultant and working on a variety of technologies that we were looking at during the slideshow that Chandan was showing. Mostly working towards data acquisition and data preparation areas, and nowadays learning data analytics. But if I roll back a few years when I started Big Data, that was in 2013. So what was the need to start learning newer technologies, and why only Big Data? Because 2013 had like more than 12, 13 years of experience behind me. And all that experience involves like Java J2E, along with our proprietary skills, which was a Cordiant framework, Cordiant, which was bought over by Pega. So because of my Cordiant and Pega experience, my income was skyrocketing, like cannot complain. But since Cordiant was bought over by Pega, after enjoying income over like more than $250,000 for nearly 5 years, my income started going down because nobody was using Cordiant. And I was simply reduced to a Java J2E developer with a $60, $65 hourly rate. And definitely that was not helping, like more than 50% of a salary cut. So I badly needed to start learning something new, which enhances my value, and I become more and more marketable, because as a typical consultant, you have to stay on the top of the game. You need to know what's going on in the market. So I gradually started learning, like, okay, what's hot? What can help me to make my income grow again, like quickly? That was another thing. It has to be quick. So obviously, I noticed that big data was very hot, like Hadoop, Spark, Big, Hive, Scoop, like you name it. Like Hadoop has more than 200 components, Hadoop ecosystem, by the way. So where do I start from? And with the experience behind me, I was like confident, like, guys, I don't need to spend anything to learning, start learning. Like I can order some books from Amazon, check YouTube videos, research material, and I can get started. And that's exactly how I got started. But what was happening is, without proper guidance, my timeline was like those things which should take like few weeks, I was taking few months to learn. And the problem was, like, by the time I finish one version, newer version will come in play, and then I have to start all over again. So I lost lots of time, just studying on my own. The good thing was, yes, I was able to learn the fundamentals. But you know what, like when you are going towards big data or after enterprise experience of more than 12, 13 years, you don't want to be stuck with hello world kind of a game. You need to bring in enterprise experience before you can go for interviews, or you can even pass certificate exams. So I thought, like, if this is taking too much long of a time, let's start taking some courses. So I checked out, like, okay, at that time, Hortonworks was Hortonworks Cloudera. There were big names in the big data industry. They were putting lots of efforts in enhancing big data technologies like Hadoop and whatnot. So I thought of appearing for the certificate exams because it helps to increase my value. And you know what, guys, like failed those exams because the efforts were, I was learning everything and it was not enough. So I thought of, okay, let's do some training. What are the options available? So options were like online classes, in person, universities are teaching, vendors are teaching, free courses. So from free courses till vendor offer courses like up to $3,000 for 40 hours of a class. Now, where do I go? I was asking two questions to all these trainers. after finishing the course, how will it increase my value? Will I be able to pass technical interviews? Will I be able to pass certificate exams? And nobody gave me any convincing answer. In that case, I said, well, where do I go? Whom to pick? Because nobody is guaranteeing me anything. And they were right in their respective ways, because it has to do with what's your background, how many number of years of experience you have. But as I said earlier, like, I wanted to turn around things very quickly because I couldn't survive with more than 50% of salary cut. So obviously I went for certain projects, which was like big data projects, dealing with at least petabytes of data and not few gigabytes, or not a hello world kind of a thing. Did those projects on my own, took some training which provided enterprise experience. Nowadays, training in big data, somebody says we offer like hello world in big data, doesn't sound good. It's like a joke. You need to work with clustered environment, petabytes of data, so that you gain value. You can build something you can be proud of, and you can show it. You can put it on your GitHub, put it on your Stack Overflow, or talk about it in the interviews. And after actually working in those projects on my own, spending lots and lots of time, I was able to get my first contract as a big data developer. And since then, learning hasn't ended, because nowadays I realized back in 2012-13 that, guys, if a technology goes down, what are my options? I don't want my value to go back to zero. So that's why I keep learning. Like today, nowadays, I'm spending heavily time with Kafka, Nifi, Elasticsearch, Cassandra, KDB, and just to keep increasing over the value, because big data alone may not be enough to make yourself more marketable. That's why you need something like, okay, can you process the data using streaming technologies, or can you do some analytics? So these are all a blend of different technologies. You decide, pick and choose which one you want to master it, because there are so many things out there. Whatever being taught, it's not what's offered in the job market. Whatever I do in the job is not relevant for my next contract. So to judiciously manage the time and pick up the components wisely, so that I can be more and more marketable down, like years down the road, and I can share my experience with the community, and with that intent, continue learning all the times. And the beauty of this technologies is it's vendor agnostic. Quadient was brought over by Pega, but I don't see like open source technologies like Kafka. Yeah, you may have vendors who specializing in customizing all those things, but at least knowing this open source technologies which are vendor agnostic, it will keep you marketable, employed with a very high value down the road. And today, I'm very happy that I haven't turned around the tables 100%, but at least I am on the right path. Any questions?
Okay, thanks, Hiren. So that was Hiren's perspective, because he's from a software developer background, and how to get into data world. So basically, data world is like when you want to get into it. So first you have to remember you are a developer, don't forget it, and just add on to it. And when you are talking about any kind of learning or training, make sure that training always have enough substance to it. Not just because doing hello world, you don't have to do anything. It's like anybody can do hello world. The key is that ability to deliver a solution using, and that doesn't come very easy. You have to spend a lot of time, and you have to be consistent with that. So having said that, so now I'll invite Shailendra. He has actually experience he's coming from data side. So how he'll explain how he has actually started his career using mostly in Excel-based analytics, to now he is a very well experienced true data scientist. So I would like to welcome him now.
Thanks, Chandan. So this is Shailendra here. So just to give you some background about me, I am an econometrician by degree. I did my master's in econometrics and statistics, and as well as software right from the college. So when we started the weapon of choice for data science and analytics. At that time, everything was known as analytics. Data science, the name data science didn't exist. And talking about 2005 and 2004, we started with SAS and Stata. And these were the two weapons of choice at that time. And also there was another software called SPSS, Clementine, which Clementine was a company and which was later on bought over by SPSS, and ultimately even SPSS got bought over by IBM, and even now it is known as IBM model, right? So we started with what you can say licensed software, very organized and truly designed to handle only structured data. So when we say we started with a lot of Excel-based data, what we mean is that we started with a lot of structured data and not very large size data or large capacity involving stuff. For example, when I joined my first bank, I was given a master computer. I mean, it was known as a master computer, but you would laugh when I will tell you that the RAM that machine had was the best across the whole organization, I would say, and that RAM was 1 GB. So now my phone has 6 GB data, 6 GB RAM. So that's that's how the journey started. So and today, when everybody talks about machine learning and data science, so what you must remember is that all these practices and all these terminologies have come into play because of these advancements in the computing power and the storage power. If you take away the computing power, you don't need Kafka, you don't need big data and blah blah blah. Everything goes back to the simple stuff. Now, how did I make the transition from there to where I am now? So we started with SAS, and SAS itself as a licensed software, it has continued to evolve. I started with using SAS on a Linux and you can say a Unix platform where you needed to code in one window and then open another folder to check the log in a .lst file and so on and so forth. That's how we started. But the main purpose of doing all that was not to master the software. That was never the purpose. The main purpose was to answer the business problem or to generate the insight. And that's where the job of a data scientist or an analytics person is different from a data engineer. Data engineer doesn't care for what the insights are going to come out of the data, right? Or what can I do using the data? All that he has to figure out is what is the best method of storing the data and maybe managing the data. Okay, how to merge something, how to aggregate something, how to make sure that there is only one version of the data everywhere, and how that everything is synchronized. That's what data engineering is all about, And if you are using a model, let's say a machine learning model, whatever, how do we make sure that it continues to run without fail, and how do we make sure that it does what it is supposed to do without any abort issues or without any errors, right? Data science is all about the first question a data science has to ask: why am I supposed to do what I'm asked to do? Okay, so if, for example, I have done extensive consulting for banks across the world. I have worked for banks in India, in Middle East, in Europe, in North America extensively. I have worked for telecom companies in Middle East and in India. I have worked for fintech companies across Europe and Canada. So I have seen a lot of world, I would say. And I have used extensive software. If you have to say, it was DITA, then it was SAS, then it was IBM, SPSS, and then everybody started moving towards R, then everybody Python, and now it is Spark, predominantly PySpark, and then you have so many other parallel streams to it. Okay. What is imperative here to understand is, it's not the software that makes you a data scientist. So if anybody of you thinks that by learning Python or by learning PySpark you will become a data scientist, no. Data scientist means that your purpose of your job is to come up with an insight, right? That's it. How do you generate that insight is none of anybody's business, right? So if you go to a client, if you go to a CEO of a bank and you tell him, hey, I have a solution, I have a methodology that I can reduce your fraud instances by 20%. He doesn't care that you have designed something on R or Python or Spark or something. That's way down the line when some tech guy will ask you, okay, how do I do that? But what he wants is whether can you really decrease my fraud by 20%? So that's the question. So let's just be very, very clear about it, that just running the models or just being able to type a code doesn't make you a data scientist if you can't understand the business context, and if you can't get back to the dollar value of whatever you are doing. Right? For a data engineer, that coming out with a dollar value is not that important, and it may not be even possible. For example, if I have to move data from point A to point B for some other larger perspective, that data engineer will never even have the opportunity or the requirement of estimating how much dollar value it will be saving or it will be costing. Right? That's someone else's job. Right? That's the finance job. But for a data scientist, if he is doing something, he always has to remember that whatever he is doing, it has to return a dollar value as a result of that whole project. Right? Now, is somebody trying to ask a question? Anybody has a question or anything, you can ask, because I don't want to make it a one-way traffic for sure. Okay. Anyways, going forward. So how do you move ahead if you, let's say, if you are starting as a newbie and you don't know anything about data scientists? So I will not be very strong in my opinions. Why? Because strong opinions means assumptions. And the first rule about data science is you don't assume. If you are assuming, you are not needed. You are a sales guy, right? So don't assume anything ever, right? Always test it. Validate against the data. That's your job, and that's what your DNA should be, right? So I would not say that if you are a software engineer, you cannot become a data engineer. No way. Or data scientist. I will not say this ever. Why? You can always do that. It's up to you, right? So anything that you achieve is just a function of your motivation and the amount of time that you invest in it. As simple as that. There is nothing else that it takes, right? Some people take longer, some people take smaller time, shorter time, and that's just about your motivation and your capability. So no discussions on that side, right? What I want to stress out again is that if you are thinking about moving to a data science role or a data engineer role, you should always remember one thing, that for every field, there isn't a what you call shortfall of people, right? There are always some people ready to do something or the other, right? So when you decide to do something, you should always try to do something which is very relevant to your past expertise again, right? So after doing 10 years of software development, and when you have done good stuff, you suddenly decide to change to a data scientist role, and let's say you want to look up freshly in the market, you don't want to just switch over within your own company or something. Maybe you will take a very large hit at the beginning. In future, in due course of time, maybe you will make up. I don't know. I can't comment. But if I were to be making such a choice, I would rather want to be a very, very smart and very, very capable data engineer than a data scientist at the beginner level, right? And the other way around. So, for example, I am an econometrician by degree. I can do my stuff on PySpark. I can code extensively in Python. I can do R. But if you say, am I a Python developer? No, that's not my forte. I don't want to be a coder. It's not my ambition. I don't want to be a Spark coder, for sure. I don't care about Scala. I am not going to put my time to learn Scala, even if it is one of the hottest things. Why? Because it doesn't fit my larger game plan, right? So I am a problem solver, right? So as I told you about my experience, I worked in banks, I worked for telecoms, I worked for whiskey companies, I have worked for automotive companies, I have worked for airline companies, I have designed fintech products, financial technology products, on big data platforms and all that. So that's my role, right? That's my job, basically, to solve something. So it's all about interest, and it's all about your readiness to take up something, right? So always try to be aligned to whatever you have done, if possible. If not, if you really want to take that jump, do it. But make sure that you get the direction right. For example, when I started learning about big data, someone told me that, R and Python, they are all bullshit. I didn't know much about Python at that time. I will be very honest. I knew a little bit of R. Somebody told me that, it's a waste of time if you are wasting your time in learning Python. You should straight away go to Spark. And I jumped onto Spark. And I'm telling you very honestly, I kept jumping in Spark for 4 months. I could not even get to import a CSV file in Spark. I couldn't do that. Even though I had all the internet and all the facilities and everything, I imported, I saw, but I couldn't visualize what do I do next. I could say that yes, I learned Spark in 4 months, but I couldn't do shit. As simple as that, right? Then I met one of my mentors, and he told me that there's always you don't just go on the roof of a house. You start from the ground floor, and then you take a stair or a lift or anything, and you jump up slowly in pieces, and then you reach the roof or reach the terrace, right? So that's what I started doing. I first learned Python. I started making sense of it. I got to know, okay, it's a new tool, just a tool to make sure that you can do everything that you know about data handling and data modeling. I could do that. And then once I was confident enough in Python, then I moved to Spark using PySpark, and then I could make sense of it. First of all, I realized, why do I even need PySpark? If you don't understand that, then you are just wasting your time, right? So it's like, if I have to plaster my walls in my house, I'm not going to use a JCB, right? Even if I have the best JCB in the world, I'm not going to use that for plastering my house. Maybe breaking my house, yes, but not plastering, right? So you need to understand that if you are only talking about a tool and you don't know where to use it, then you are an idiot. And you have no place, right? So first question yourself, if you want to learn something, why do you want to learn something? And where will you use that tool? Right? So be it Python, be it PySpark, be it R, or be it any machine learning technology, right? Because I work for a company where somebody told me, hey, we developed an XGBoost scorecard for this particular problem, and it's working fantastically. So I just asked her, okay, what is XGBoost? She said, no, this is all that I could get from the internet, and that code worked really well, and it has worked extensively well, and I got a very good AUC of 0.89. I said, okay, fine, but how is the model doing in out of time? And I said, no, actually out of time it's not so good, it's only 0.62. I said, it means it's a bullshit model. And when you can't even explain what is an XGBoost model, you can't call yourself as a data scientist, even if you can run that code. Why? Because you don't know the basic premise of XGBoost. Maybe that's a completely wastage of time. Maybe a simple logistic regression would have worked well, or maybe it needed light GBM, or maybe a neural network. So if you don't know the theory or the logic behind it, why it works and how it works, you will never be able to make it better. Anybody can code. Anybody can make a predictive model. But somebody with the domain knowledge and expertise will make a predictive model which will actually work. Okay? So somebody is chatting. Okay. So somebody could not understand. Anyway, so the point is, you should always try to stay relevant to your path. And if you want to do data science, very good. So just get into some of the basics, like understand what is a regression, what is basic statistics, how do we go ahead with that, what is a machine learning algorithm, and what exactly it tries to do. Okay, so once you have made sense of it, then Python, PySpark, and all that are tools. You need to get the context right, and you need to have the direction right. Okay, so for example, here in our Cloud Ready platform, we have multiple levels of trainings available, right? So some are just like for initiation, some are for advanced levels. So you need to be able to select what you want. To begin with, do you want something directly jumping the gun, or you want to start slow? That's completely your decision. Okay, so I give it to Chandan.
Okay, thanks, Chandan. So this was, I think, today that's all we have. Unless you guys have some question, and feel free to subscribe to our YouTube channel for any such webinars. And we are planning to have these kind of webinars on a weekly basis. We'll touch base on something, and we'll try to discuss it. And you can join our community on bcloudready/forum. You can join Q&A. It's a free Q&A section, and there are a lot of resources for you to read over there. And you can post any question if you want. We will be happy to help. And leave a comment below if you think anything maybe you should include in the next webinar. Thank you. I will wait. Anybody, any question? If no question, then we'll just hang up. Okay. So thank you, everybody. Goodbye.